Okay, good afternoon, everybody. This is a supplemental lecture that I developed after an email conversation this fall with a member of the class, and it became apparent that backing up a little bit and talking about academic writing might be a good thing to do. And I had the idea to equate the academic writing process to systems engineering or software engineering life cycle. Um, they're absolutely parallels. And since everyone in here is a computer science genius, I thought that this would really hit home with everybody, and it would avoid problems that we had with the most recent writing assignment being off topic, or not satisfying all of the requirements from the instructions. So here we go. This lecture shouldn't take very long, and hopefully it'll be helpful for you going forward. Okay, so I'm calling this academic writing for systems engineers, um, and you'll see why here in just a minute. We're going to briefly talk about the systems development lifecycle, software development lifecycle, the good old SDLC, very much waterfall, um, and it's used for a bunch of different design methodologies or development methodologies. So we're going to focus on requirements, design, code, and uh, documentation, but I'm going to use slightly different terms to match the SDLC here. Okay, so here we have uh, the tried and true software development lifecycle. Uh, Starts at the top of the circle, and with requirements. Uh, the whole reason you're developing a system, developing software, um, is to satisfy some set of requirements. Then we move into design. We take those requirements, break them down, decompose them into manageable chunks of functionality. Maybe some of that stuff will be off the shelf. Some of it will be custom coding. So we design our system all the way through. Then we implement it with code or with COT software or whatever the case may be. Then we test it and then go back again. So there are a lot of parallels with developing an academic paper, almost like you would develop a computer program. So um, starts off with requirements analysis. The requirement for your papers comes kind of in two parts. There's a standing requirement, just like if you're writing software at the enterprise level, you're going to have standard libraries you have to comply with. You're going to have coding standards. You'll have configuration management software. You have to check things in, check them out, and you'll have standards that you have to go by. For no matter what the software does, you'll have these requirements to satisfy. And so I thought I'd use that corollary to talk about things like every paper in this class is going to need to be APA format. Some folks were turning in papers where the paragraphs were not indented. That's an APA basic formatting requirement. Some people are adding references that are just a URL, where there's a standard format for all APA references. All papers need to have academic tone. Generally, you write in third person. They all need to standard academic writing requirement. You support your main points with literature. You don't just some folks I think are just throwing in a citation just to make it look like a citation belongs there, but the work that you're citing has nothing in it that backs up your point. So it's don't just go through the motions. Actually, use make sure that there's some sentence or passage within that reference you're citing that reinforces your point, that makes your point for you. Um, and then, of course, all papers need to be original. And I posted an extra presentation one of my colleagues on the faculty developed that talks about paraphrasing what it is and what it is not, and the epidemic problem that we're having in discussion and with papers. So those are standing requirements, but every paper you write will also have to comply with instructions. I got several, more than I should have. Several papers turned in that had absolutely nothing to do with the instructions, not anything. So that's almost like just going out to GitHub or some repository and just grabbing some software and throwing it at your boss, saying, "Here you go." Uh, it doesn't comply with the spec. It doesn't comply with the requirements. So instructions are like user requirements. Okay, so everything you write needs to be traceable. Every paragraph you write needs to be traceable back to a requirement, just like every piece of code you write will trace something. It will trace back to a user requirement, or you're doing it wrong. And the 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 bottom line is, you can write a great piece of software, you can write a great program, but if it's the wrong product, if it does something different than what your user needs it to do, you failed. Um, so all parts of the paper should trace back to the instructions. So when you're writing, when you're looking at this thing, make sure that you're constantly reminding yourself of what the instructions asked for. I don't look for anything in your paper that's not in the instructions. A brief overview, brief, like literally 3 or 4 sentences, and then you get right to it. I love a concise 2-page paper that uh, is really easy to see that you are satisfying the assignment instructions. Okay, so you've got your requirements. Then you move into the design phase, just like in software. You never pull up an IDE and start slamming away, writing code um, to satisfy, after having had a conversation with a user. You always look at how that change is going to be implemented and in some form of design. Well, the same thing is helpful in writing. I've seen some papers where I can tell you guys have uh, written yourself. There's a metaphor when you're painting a floor, and you paint and you paint and you paint and you back up towards a corner, not towards the door, and you've painted yourself into a corner, and now you can't get out, or you'll step on the fresh paint. That's a metaphor that's used sometimes for not thinking all the way through to the end of a task when you get started. And I've seen some papers that look like people started typing, but didn't really have the end in mind. They didn't have the entire paper designed or outlined prior to writing, and that's an important step to do. That is uh, making sure you have an outline. Now, uh, uh, I recommend a full sentence outline, and the way I outlined all of my papers, and I've posted several in the first week of class Walker writing samples. Is I would use the template APA paper, which I've also posted, and I would go in and I would write my headings. And for these short papers, I just use the level 1 heading where it's centered and bolded. So I would write out those headings. If the paper was asking for me to compare, 3 different things, I would have a heading for each of those things, and then I would have a conclusion and an introductory paragraph up front. They're too short for abstracts. You don't need an abstract in any of the short papers we're doing. Um, so that's how I would outline that gets you into the template so that you know you're using the right document to start with. But it also makes sure that you have some kind of an outline. Now, in addition to the headings, I would also write a topic sentence. The first sentence of a paragraph should alert the reader as to what that paragraph is about, and then you stick to one idea in a paragraph, but we'll get to that a little bit more in implementation. Um, oh, and in design, that's a good time to go through, find some articles that talk about your subject, browse through them, find some key points. Generally, in the findings is where you find something that supports a point. If a journal article did a study and they found that X equals Y, that's a good place for you to reinforce points in your paper. So I would also have basically my reference list finished uh, during design as well. And then once software is designed, you move into implementation. Um, most most shops have some kind of a design review. Of course, you're working alone, so you'll have to do your own. But once you're confident that you've got a good outline for your paper, and you just need to add the paragraphs that support your main points, you can start writing. And then there's a correlation with coding and writing. It has to be correct. uh, if you get a syntax error in Java or any other language, and you go to compile it, uh, you'll get an error. Well, there's syntax in English as well. That this is the time to make sure that you've got your syntax correct. But then there's also runtime errors. You might have a paper that comes back with a strong Grammarly score because uh, all of your periods and commas and your spelling is correct and whatnot. But that doesn't mean you've got a good paper. It's got it's got to run well. Uh, uh, it's got to flow. Well, I'll go into that a little bit more. Good coding techniques mirror good writing. When you're programming in any language, there are standards of good code. And I know the whole tabs over spaces argument, but you indent code so that it's readable to the human eye. You use meaningful variable names so that someone coming after you or you a year later, you can easily read what the code is trying to do. Well commented code. So good. There are good coding techniques. There are good writing techniques. Um, and like well performing software, your writing, your paper will perform well. It'll flow. And I use some terms here. You hold your reader by the hand, of course, metaphorically speaking, but you are the writer. You are the author. You have to don't make any assumptions. You take the reader by the hand and walk them through your main points. Generally, these research papers are stating some sort of fact that you then back up because you've got literature to support your main premise. But you have to walk the reader through your logic step, and this will become increasingly important as you get to your literature review. Um, you will justify your dissertation through your literature review by walking the reader through what research has been accomplished uh, in the past. And it has to be smooth, it has to be accurate, it has to be complete. Um, so you will be leading your reader on a journey, and you have to transition smoothly between topics. If you're unfamiliar with the term, um, it's a grammatical topic you can Google and get some good examples. A transition sentence, generally at the end of a paragraph, you kind of wrap up what you were saying, but then you can also sort of lead into the next topic. And that's a good transition. So if this is just being an example, if if the subject of your paragraph is that football is uh, football is fun to watch, but you want to transition into the fact that it's also fun to play, your last sentence could be something like, while millions of people enjoy watching football, comma, there are also many who enjoy playing it even more. And then your next paragraph goes on to talk about the leagues and the different ways you can get involved in playing football, something like that. Just an example. So you transition at the end of a paragraph. You would transition the reader uh, to the next topic. And you're just like code should be elegant. Uh, Software should solve a problem elegantly. Um, and as opposed to a kludge or something that takes a bunch of unnecessary steps or um, doesn't use doesn't take full advantage of the language or of libraries where elegant, simple, understandable. Simple is better than complex. Short is better than long. That's all what I mean by elegant. Um, Never write beyond your grasp of the topic, and that's what happens with these rewording websites and paraphrasing websites is they start to spit out stuff that you're not able to defend verbally. If we were to sit down with one of your papers at the residency weekend and start going sentence by sentence, um, make sure that what you put on that paper is something that you can explain when you're sitting across a table. Never write beyond your grasp of the topic or the language. Don't use words or phrases that you're not comfortable with are are the correct usage and meaning. Again, you're all seeing it. You're seeing discussion questions, at least that are being answered with a lot of very flowery language, but no real um, personal attention to the topic or personal experience shared. It's just uh, pontificating. So yeah, right within your grasp of the topic and the language. Okay, so that's during implementation, and then testing. Just like software, you once you once you write the code, you got to run it and test it. And well, running there's a couple of ways to test your writing to stay with this metaphor. Submit through Grammarly. You all got Grammarly free from the university. So that might identify bugs. I know I've seen some papers that get submitted and they have just what should have been just a spelling error that Word would have caught. So make sure that you're using all the tools: Word, spell check, Grammarly, um, anything else you can think of electronically to check your paper. Run it through it again and again, as many times as it takes to come to grips with all of the problems. But then, just like in code, you can have a peer look at your code or your paper and do a peer review. I would recommend you find a colleague that has strong writing skills, and you let them read your paper and give you some feedback. Um, I think absolutely 100% of the class would benefit from that for every paper. Uh, I recommend using a native English speaker um, that can help potentially with colloquialisms and subtle turns of phrase to help you write more confidently um, and confidently and correctly. And then yourself, just like you would, with your own software, you play computer, you go through instruction by instruction and make sure that you've coded it up right. But ask yourself, pull up your paper in one window, pull up the instructions in the other. Go back between each one. Have I addressed the required information? The instructions I post are not long, but folks are still not answering that primary fundamental question. Um, and then, are my main points reinforced by references? I will often see fairly bold claims being made in your papers and without any support. Now, in your dissertation, I'm not as strict in class as it will have to be for your dissertation, but you can make no statement of fact in a dissertation that is not reinforced. So if you say the sky is blue, you have to cite the study that proved that the sky was in fact blue. Um, that's just the way it works. You don't have standing to declare anything. So kind of get used to that concept in your papers, but especially for the main points of your paper. Um, Make sure you've got some sort of reference that backs that up. And when I ask for recommended research, I don't. A lot of you are just putting what you recommend, and that's not what I'm getting at. Every article you read virtually has a section in it for recommending future research. Um, read them. A lot of those will be justification for an entire dissertation. So make sure you're reading those in all of uh, um your articles. Make sure everything's in APA format. You got headings, indented paragraphs. You've cited every reference, listed the reference for every citation you make. Times New Roman 12 pitch font, all that, double spacing. And then ask yourself, have I taken my reader on an enjoyable, smooth journey? That requires a thesis sentence up front that tells the reader what you're going to tell them. It requires paragraphs that map to that thesis sentence, so that if you say, international trade is fostered by A, B, and C, if that's your thesis for your paper, then you've got to have a paragraph with a topic sentence that says A fosters international trade by whatever. And then you got to have another paragraph that says B fosters international trade by doing whatever B does, and C. And then you conclude. Don't add a D. That's not taking your reader on an enjoyable, smooth journey if you introduce a fact that's not in your thesis sentence. See, it's very structured. So it's very much like code. You can't, in a lot of languages, you can't use a variable that you have not declared previously. Well, don't introduce facts that you haven't introduced in your paper. Don't, or topics. Don't go off on a new topic that you haven't introduced uh, or prepared the reader for. It's got to be smooth from subtopic to subtopic, and at the end, you wrap it up. You don't introduce some new fact, but you maybe can summarize your bottom line with a reference in your conclusion. And you kind of that's where you just reassemble all the facts into one small paragraph and get off the stage, as they say in TED Talks. Um, okay, so um, in conclusion, I'm still seeing um, rewording and paraphrasing website output, or manual rewording that just is unintelligible. And it's never going to produce the desired result. So the sooner you stop relying on those things, the sooner you'll start getting real practice. And then uh, just like in software, it gets exponentially more expensive and difficult to fix a problem the further you get through the cycle. If you catch something as a requirement, sometimes the cost might be zero. But if you get all the way to testing and figure out that you missed a requirement and now you got to go back and change the design and figure out how to make that new requirement integrate with the previous requirements, and then you got to make the code talk to each other to integrate that. It gets expensive or maybe even impossible. Well, it's a lot like that if you get going down the wrong road, and then like some folks, the topic was globalization this week. Somebody, maybe say somebody turned in a paper when it was supposed to be about globalization. They turned in something that was just generically about blockchain, say. Well, you can associate blockchain with globalization and business to business transactions and some other issues that are happening. Currency that's outside of the purview of any particular nation state. There's ways to correlate blockchain and globalization, but you can't just write about blockchain by itself as a technology. That doesn't satisfy the requirement. So uh, that person would, if they had caught it before they turned it in, they would have had to really go back to the beginning, read the instructions, analyze the requirement, and design a paper that actually equated or related blockchain to its effect on globalization. There's research out there in it, but if you don't do your requirements analysis up front, you miss it and you turn in the wrong paper and you get a zero. So just like in life, if you turn in code that doesn't match the spec or is oblivious of your user's requirements, you get a zero, which is $0 put in your paycheck because you're fired. So that's why I don't regrade. I don't forgive or any of that, any of that, because the world's not forgiving. So make sure you do your requirements analysis and make sure you do your design. Uh, that's my third bullet there. Writing without an outline is like coding without a design. It's just not done in the production software world. So I hope this helps. Any questions or concerns, feel free to call or email me. Okay, everybody take care.